Now let's talk about promises, okay? I know we're running late. If you have to leave, it's okay, I understand. I'm trying to get through it quickly, but this is the stuff I'm actually most excited about, so I hope this is interesting to you. Promises. Promises, there's a lot of different ways that people explain them. There's a whole bunch of great blog posts about promises. I encourage you to kind of take a look at some of those. Let me just give you two metaphors for what a promise is all about. Okay, the first one is you walk up to the counter at Burger King or McDonald's or something like that, and you're hungry for a Big Mac or a burger or whatever. You hand the cashier, you order your food, you hand the cashier some money. What usually happens is you don't have your food back right away. What does the cashier hand you instead of your food? A receipt, and that receipt has an order number on it. So you step back among the other masses of people that are impatiently waiting for their high caloric intake food, and you wait patiently, unpatiently, for somebody to call out that order number, that magic number on your receipt. And then what do you do once they call out your order number? You walk back up to the counter and you exchange your receipt for the food that you actually wanted. So what we have here is we have a transaction that was asynchronously completing. I started the transaction by giving you some money, but you couldn't complete the transaction and give me my food yet. You had to give me a promise for some food. You had to give me an IOU for some food, and you had to come back at a later time and exchange my order number for my food. Okay? That, metaphorically, is exactly what promises are. I call to a function, and I want some end result to happen, and that function tells me, sorry, I can't finish it yet. But I'll hand you back a promise, I'll hand you back a receipt with an order number on it, and at some later time when I get finished with that task, I'll let you exchange the order number for the value that you asked for. Does that make sense? All right. The other metaphor that I would give you for promises is, what if we could call a function and we weren't sure when that function was going to finish, but what if we could subscribe to an event? After calling the function, we had some mechanism by which we could subscribe to an event that lets us know when that function finishes. We might call that a completion event or a continuation event, kind of like we listen for click events on buttons. But this is an event for a function call. That's essentially what promises are. We're calling a function, it doesn't finish yet, but it allows us to subscribe to a continuation event. And when we get notified of that event, then we proceed. Does that make sense at all? Let's see what that looks like in code. I'm going to use, this is very heretical in the broader standards community, because everybody seems to, in the standards community, they seem to universally hate the jQuery implementation of promises, because jQuery had the gall to implement promises in a non-standard way. And jQuery can't go back and change it now because there's 10 million lines of code relying upon it. So if you talk to anybody in the promises and the standards community and you mention jQuery promises, they will scowl at you and say, oh, you shouldn't be using those. I think that's hogwash. That's nonsense. jQuery has promises. They're useful. It's a pattern rather than an API as far as I'm concerned. So I'm going to show you first how jQuery does it. We create these things called deferreds, and we pull a promise object off of our deferred. Then we have two separate pieces of code. Lines 4 through 6 and lines 8 through 10 would likely happen in totally different places in our code, because it's a separation of concerns. Lines 4 through 6 are what happens when we want to listen for the event. In this case, we want to listen for the done event, the continuation event. So we would return back a promise from some utility, and that calling place would be able to listen for the event that was finishing. And then somewhere inside of our code, we would, at some later point, we would resolve that promise. We would exchange the order number for a Big Mac. So when we call resolve on the deferred, he will automatically fire the done event for any promises that are listening to it. Okay? Here's how we use it. For example, creating ourselves a little delay function that I call wait for n. I create my deferred, I return my promise, I set up a timeout for calling d.resolve. That's the typical pattern. And you'll see that with all promise implementation, that same kind of pattern. Okay? So here's how we use it. We call wait for n 1,000. Wait for then 1,000 returns us back a promise. So when we call .then, we're listening for the continuation event on that returned promise. So our code says wait for n, wait for 1,000 milliseconds, then do this stuff. Inside of this stuff function, we call wait for n again, which generates a whole new promise. And when we return a new promise from it, it chains the promises together. So this code, you can look at it very synchronously. It says wait for 1,000, then do this, then do this, then do this, then do this, even though it starts and stops asynchronously. So you can see that promises give us something similar to what we saw with generators. They give us a very synchronous looking syntax for an asynchronously completing series of tasks. Does everybody follow that? Now here's why it's important. Remember when we talked about inversion of control? When I pass a callback into some utility, that utility has control over when my code happens. We've reinverted the control. We've uninverted the control now. We call some utility, and rather than giving them our continuation, that utility hands us a promise back. And we get to decide what we do with that promise. We listen for the completion of that promise, and we decide what to do next. So we've uninverted that inversion of control and brought it back so that we are now in control of the entire completion of our program. Does that make sense? That's why promises are such a powerful solution to callback hell and inversion of control, is because they uninvert that inversion of control. Now, promises are actually built in as of ES6, so you can use them natively directly in the language. We're going to get the capital P promise. It's built in. It's already there in Chrome and Node. You can play with it if you want. We construct our promise. This should look very similar to what we were doing with jQuery. We construct a promise that we return back, and then we call a resolve at some later point. And we call .then and .then. And when we return new promises, it does exactly the same thing. This is why I don't care that jQuery's API is slightly non-standard, because the concept is the same. We still reason about the code in exactly the same way.
Kyle, is there part of that chaining strategy for each one? If you say, if I get a timeout in this one, I want to do this. Is there like a then otherwise?
Yeah, so in native promises, if you pass two functions in, the second function is the error handler for that stage. So there is a way to call reject if you want to fail a promise. There is always an error path. All right, so we get data. 1,000 milliseconds from now, it passes along this message. Promises have message passing, obviously. So 1,000 milliseconds from now, num1 will be 10. 1,000 milliseconds from now, num2 will be 30. And 1,000 milliseconds later, answer will be the string meaning of life 42.